Over the course of this inquiry exercise, we have come to understand about this new scale we can use to measure angles, which is the radian. And that the radian is independent of degrees. So we can talk about, how large an angle is without using a number that we as humans just pulled out of a hat for reasons, whether those reasons are good or bad. And that is very valuable. It becomes super valuable when you get to calculus. I won't spoil the surprise of why, but this notion of knowing what the right amount of squissification of the sine wave is very important in calculus. But since we're all used to degrees and radians are nice and important for engineering and science in a lot of applications, let's think about how to switch back and forth between the two of them. So the key fact that we learned in this exercise is that 180 degrees is equal to, switching pens here, that's just dead. 180 degrees is equal to pi radians. Or if you want to think about it in a different way, if you have trouble memorizing that, you could think that 360 degrees, which is the full number of degrees around a circle, is equal to 2 pi radians, which is the circumference of a circle with a radius of 1. So this is the circumference of the unit circle, and this is the number of degrees around the interior of a unit circle. And so let's say that we had some measure inside a circle. Let's say that this was 120 degrees, and we wanted to express that in terms of radians. Let's see how to do that. So we've got this conversion factor here, 180 degrees equals pi radians. So we're going to do that conversion the same way I imagine you did a lot of conversion problems in middle school. That we're going to put our conversion factor here, 180 degrees to pi radians. And then we're going to set up a proportion where we want to know about 120 degrees. So where should I put 120 degrees on the other fraction? Should it be in the numerator or the denominator? And why? Well, let's put it up here in the numerator because I want it to line up with the degrees in the other fraction. And I want to know how many radians that represents. I don't know what that is right now, so that's where I'm going to put my variable. And now we cross multiply, and we have that 180x is equal to 120 pi. And so all we need to do to figure out what x is divide both sides by 180. And we have that x is equal to, and one of the nice things that you probably discovered in part 1 of the exercise is that one of the nice things about 360 is that a lot of numbers evenly divide into it, which is very attractive. So I could divide both sides of this by 60, and that would become a 2, and that would become a 3. And so an angle of 120 degrees, I could express that as 2 pi over 3 radians. And you'll find very often when we talk about radian measure that we're just going to keep the pi in there. We're not going to try and multiply that by 3.14 or some even more complex version of that. If I express it as 2 pi over 3, then that is an exact value. And that has some importance. So keeping pi in your radians is a very common thing to do. And if you had a problem where you had some number of radians and you want to convert it into degrees, you would just do the exact same thing, except you'd put the radians in the denominator and x in the numerator, and then solve for x. So hopefully that gives you a little bit of familiarity about how you do conversions in general and how you do conversions from degrees to radians specifically.